Hello friends, this is Eli with Mystic Circuits. Today I want to show you how to use the Vert as a bit crusher as well as a wave folder, and we will also show how to use the switches expander as a ring modulator. What sets the Vert apart from most bit crushers is that instead of removing bits until we are left with a square wave version of our original signal, we have individual access to all 8 bits. Now in this case, I'm driving the Vert with a simple sawtooth wave from my Synchrodyne by WMD, which if we set this to the right input amplitude, the bottom bit will give us 1 pulse per oscillation cycle. Bit 7 will be 2 pulses per oscillation cycle. Bit 6 will be 4 pulses per oscillation cycle, and so on. If you don't understand why this works, I suggest you watch a great video explaining the binary functionality of the Vert by my good friend Joe over at Control Voltage Lab. Really, his whole channel is worth checking out, and I'll link to that in the description. And the end result of all of this is that each bit will hypothetically give us an octave doubling of the previous bit, until at bit 1 we have a signal which is hypothetically 256 times the frequency of the input signal. I say hypothetically because the internal sampling clock limits us in most cases, but the top output will still always add a lot of very pleasing high frequency content. Now, I'll keep our input at a steady frequency, and we will listen to all the outputs so that you can hear the octave doubling effect. We'll start actually with bit 7 since the input amplitude is a bit low to get a good frequency doubling effect, starting with bit 8, but as you can hear here, this is our fundamental. 1 octave, 2 octaves, 4 octaves. Yeah, you get the idea. Here we are at the top with our very high number of folds. And a very interesting side effect of this is that we can actually control the folding octave doubling effect by changing the input amplitude. We can do either with an input attenuator or with a uVCA. Now, the Vert is slightly unlike other analog wave folders in that you usually can only get 6 folds at best. But the Vert can fold an input signal up to 256 times. This allows us to listen to LFOs and turn them into strange audio pulses. If you watch this indicator, you can see right now that I'm turning our input signal into a very slow oscillation, and we can actually listen to this by turning up the input amplitude because we're folding the signal a whole heck of a lot of times. And of course, the number of folds is controlled by the input amplitude again. So now we can control this entire effect with a voltage by first plugging our input into a VCA, as so. And then I'm going to send an envelope from my Frequency Central System X envelope into the VCA. Let's put in some good parameters, and then I'm triggering my envelope from the Rene, and if we turn the input amplitude up, right now our VCA is just at a high bias. You can hear changing the amplitude again, and then if I want to control that with a voltage, you can hear as that signal goes high, we get more of a wave folding type of sound. And you can control the overall wave folding effect by changing the input attenuator on the Vert. Something to notice is that at lower bits, we get something somewhat more similar to a comparator or pulse width modulation than a wave folder. Let's go even lower than that. Another interesting effect we can achieve with just a Vert is that if we listen to a higher bit and then lower the internal sampling clock, we can change the Vert into a downsampler. This is much more apparent at higher bit values. So if we go all the way to the top, here we get all that crazy high frequency goodness. And of course we can voltage control this effect with the FM input and attenuator. Now, let's turn our attention to switches. In this case, I have my drums going into bit 4 of switches. Turn that up a little bit. Bit 4 is one of the clean inputs, meaning that the switching is done with high frequency switching IC or microchip. Since the Vert is driving switches at audio rate, we are turning on and off the audio coming through each of the inputs in such a way that gives us a ring mod type of sound. Here that changing the input amplitude of the carrier still gives us a wavefolding type of sound. Turn up the bias. These are kind of typical ring mod type of sound. Lower frequencies, we get more of a stutter. Still with the cool wavefolding effect, also downsampling. Another thing is that since we have 4 inputs, we can actually put more than one thing into each input and ring modulate them separately. Here I have both of samples coming in. Just the vocal sample.
Note the ringing quality of the orchestra bell. The delicate feeling of the violin.
Sequence the pitch of the ring modulator carrier and modulator oscillator. Again, using a higher input will give more high frequency content. Using a lower input will give less high frequency content. Change the sample. There's a little bit of bleed because the oscillator is turning on and off this switch at audio rate.
Remarkable separation. The gals on one side, the guys on the other. That's the way you hear it in person.
Anyways, this should give you a better idea of how to use the Vert and Switches expander for audio manipulation. Thank you for watching.